Now we want to continue these equations. Here the electric potential due to the positive and negative charge, or simply electric dipole at point C is what we get there, V, which is equal to the Q upon 4 pi epsilon 0 inside the bracket 1 upon R1 minus 1 upon R2. Now we want to find out the value of R1 and R2 by geometry. What we get there? By geometry. First of here, we want to find out the value of R1, right? So for that, here we want to consider the triangle. Which triangle? See here, we want to consider the triangle C A P. So this triangle. In this triangle, we want to use the Pythagoras theorem. In triangle, which one? Triangle CAP. In triangle CAP or CPA, here we want to use the PGT. As per PGT, PGT means there Pythagoras theorem. What we get there? R1 square, which is equal to the, what we get there? Here this side, that is AP square, but the value of AP square is L sin theta. So what we get there? L square sin square theta plus, what we get there? This side square, that is PC square. But the value of PC is R minus L cos theta. So what we get there? R minus L cos theta bracket square. Right? So if we expand this one, so what we get there? Which is equal to the L square sin square theta plus, here just like here we want to treat A minus B bracket square. So what we get there? A square minus 2AB, that is 2RL cos theta, right? Then plus what we get there? B square, that is L square cos square theta. So we get this equation. See here, this will be the L square sin square theta, and now this will be the L square cos square theta. So from these two, we want to take the L square is common, and inside the bracket what we get there? So L square sin square theta plus cos square theta, right? Then remaining terms are there, plus R square minus 2RL cos theta, right? We get this one. But you know that mathematical standard, what we get there? Sin square theta plus cos square theta is nothing but the 1. So that's why instead of this bracket, we want to substitute the value is 1. So what we get there? L square plus R square minus 2RL cos theta, right? Now this will be the value of R1 square, right? Suppose here this will be the equation number 5. Suppose this will be the equation number 5. Similarly, in the triangle, which triangle? In the triangle C P dash minus Q, we get the value of R2 square. Similarly, in triangle, what we get there? Triangle is C P dash B. C P dash B. As per the PGT, what we get the equation is. So we write directly final equation. Here we want to take the same procedure as we take for this one, right? So what we get there? R2 square, which is equal to the L square plus R square plus, instead of minus sign, simply we want to take the plus sign. Why? In this case, we get the values R minus L cos theta. But for this case, what we get there? This total distance, that is CP dash, is nothing but the R plus L cos theta. So we want to take the positive sign. So 2RL cos theta, right? Suppose this will be the equation number 6. Right? Now we want to find out the value of simply r1 square, or before that, suppose here if we take the value of r square is common from both, so what we get there? See here we get the r1 square which is equal to the, suppose here if you take the r square is common, then inside the bracket what you get there? Here L square upon r square. So if you take from this term r square is common, then simply here what you get there? Plus 1. Then from this one what you get there? Minus 2L upon r. Right? And this cos theta is as it is. Right? Then similarly for the sixth equation, what we get there? R2 square which is equal to the r square inside the bracket L square upon r square plus 1 plus 2L upon r, what we get there? Cos theta. So this will be the modified version of the equation 5 and 6. Now from that we know that the value of r which is very large as compared to the L. Then see here, if the value of r which is very large as compared to the L, then what we get there? R square which is very large as compared to the L square. Then we want to neglect which term? That is L square upon r square. So what we get there? Therefore r1 square which is equal to the, what we get there? R square inside the bracket, here we neglecting these terms from both the equations, so simply what we get there? 1 minus, what we get there? 2L upon r into the cos theta. Right? Similarly for the second one, what we get there? R2 square which is equal to the r square 1 plus 2L upon r into the cos theta. We get these two equations. Now we want to take the under root on the both the side. So what we get there? If you take the under root on both the side, so what we get there? R1 which is equal to the r inside the bracket 1 minus 2L upon r into the cos theta raised to the half. Right? Similarly for the second one, R2 which is equal to the r inside the bracket 1 plus 2L upon r into the cos theta raised to the half. Right? So this is about the R1 and R2. Now again here we want to take the reciprocals of this one. So what we get there? 1 upon R1 which is equal to the 1 upon r inside the bracket. Here instead of we take the reciprocal of this one, simply we change the sign of their powers. Here the sign of power of this bracket is simply positive, but when we take the reciprocal then we get the negative sign. So what we get there? 1 minus 2L upon r into the cos theta raised to the minus half. Similarly here what we get there? 1 upon r2 which is equal to the 1 upon r 1 plus 2L upon r into the cos theta which is what we get there? Raised to the minus half. Right? Then now again here we want to take the binomials expression. So the binomial expansion, what you get there? By using the binomial expansion, what we get there? If there we get the 1 plus x raised to the n, and the value of L is greater than the value of L is small as compared to the R or X, whatever, right? Then at that times we write there 1 plus simply nx, and neglecting the higher order terms. So what we get there? See here. Therefore 1 upon R1, which is equal to the, now this 1 upon R is as it is. Here this first term is as it is. Here the sign of power is negative. So when we transfer here, then what we get there? Negative, negative get plus. So what we get there? Plus 2L upon what we get there. Now this 2 is as it is. That is a 2R. Right? And now this cos theta is as it is. Simply 2 get cancelled. So what we get there? Which is equal to the 1 upon R 1 plus simply L upon R cos theta. Now this is about the R1. Similarly for the R2, what we get there? 1 upon R2, which is equal to the 1 upon R. Here we get the positive sign, but for the R2 we get the negative sign. So what we get there? 1 minus L upon R into the cos theta. So here we get the value of 1 upon R1 and 1 upon R2. Now both values we want to substitute in this equation, right?